Hi students, in the previous lecture we have seen distance of a point from a line, as well as we have seen distance between two parallel lines. Now today we are going to see the problems on distance between parallel lines. So see the first question, find the distance between parallel lines. Find the distance between parallel lines. R bar is equal to 2I cap minus j cap plus k cap plus lambda into 2I cap plus j cap minus 2k cap, and R bar is equal to I cap minus j cap plus 2k cap plus mu into 2I cap minus j cap plus 2k cap. 2I cap plus j cap, sorry, it is plus j cap minus 2k cap. See, we have two parallel lines and we have to find out the perpendicular distance between these two parallel lines. So here your A1 bar is equal to 2I cap minus j cap plus k cap. A2 bar is equal to I cap minus j cap plus 2k cap, and B bar means the vector which is parallel to both the lines, that is B bar is equal to 2I cap plus j cap minus 2k cap. We know that the distance between two parallel lines, the distance between the parallel lines, R bar is equal to A1 bar plus lambda into B bar, and A2 R bar is equal to A2 bar plus lambda into B bar is modulus of A2 bar minus A1 bar, modulus of A2 bar minus A1 bar cross B cap. A2 bar minus A1 bar cross B cap. Now here, see, A1 bar, A2 bar are here, B bar is also here. First find out A2 bar minus A1 bar. A2 bar minus A1 bar is equal to A2 bar minus A1 bar, I cap minus 2I cap minus I cap, minus j cap, and minus minus become plus j cap, j cap minus j cap plus j cap plus 0 into j cap, 2k cap minus k cap plus k cap. So this is A2 bar minus A1 bar. A2 bar is this one minus A1 bar, 1 minus 2 minus 1 I cap minus j plus j 0 j cap, and 2k minus k k cap. So this is A2 bar minus A1 bar. In this case also we require B cap. What is B cap? B cap is the unit vector along vector B. So B cap is equal to vector B divided by magnitude of vector B. Again it is equal to, what is vector B? 2i cap plus j cap minus 2k cap divided by magnitude of vector B. Magnitude of vector B is square root of 2 square plus 1 square plus minus 2 square. It is equal to 2i cap plus j cap minus 2k cap divided by square root of 9, and we know that square root of 9 is 3. So b cap is equal to 2i cap plus j cap minus 2k cap divided by 3, or which can be written as 1 by 3 into 2i cap plus j cap minus 2k cap, or which can be written as 2 by 3 into I cap plus 1 by 3 into j cap minus 2 by 3 into k cap. So this is your b cap. What is b cap? Unit vector along the vector b. Now we have a2 bar minus a1 bar as well as b cap. So the required distance, or the distance between the parallel lines is equal to, see, a2 bar minus a1 bar, that is modulus of a2 bar minus a1 bar. a1 bar is here, a2 bar minus a1 bar cross b cap. It means first we have to find out a2 bar minus a1 bar cross b cap. So first we find a2 bar minus a1 bar, its cross with b cap. It is equal to, you know that cross product is nothing but the determinant I cap, j cap, k cap. So second row is the coefficients of I, j, k in a2 bar minus a1 bar. What is a2 bar minus a1 bar? It is I minus I cap plus 0 j cap plus k cap. So coefficients of I is 1 minus 1, coefficients of j is 0, and coefficient of k is 1. Now coefficients of I, j, k in b cap. Here b cap is here, 2 by 3, 1 by 3 minus 2 by 3. 2 by 3, 1 by 3 minus 2 by 3. So it is equal to, say from the third row take 1 by 3 common, so 1 by 3 into 1 by 3 into this 3 by 3 determinant I cap, j cap, k cap minus 1 0 1 2 1 minus 2, and now solve this 3 by 3 determinant. It is 1 by 3 into, in bracket, I cap into, leave first row first column, so 0 into minus 2 0, 0 minus 1, minus j cap in bracket, leave first row second column, minus 1 into minus 2 plus 2, and minus 2 into 1 2, so it is 2 minus 2, plus k cap in bracket, leave first row and third column, minus 1 into 1 minus 1, and minus 2 into 0 0, so minus 1 minus 0. It is equal to 1 by 3 in bracket, see, 0 minus 1 that is minus I cap, 2 minus 2 0 that is minus 0 j cap, and minus 1 minus 0 is minus 1, so it is minus k cap. So 1 by 3 a2 bar minus a1 bar, a2 bar minus a1 bar, its cross with b cap is equal to 1 by 3 into minus I cap minus 0 j cap minus k cap. So the perpendicular distance is nothing but the magnitude of this vector, and magnitude of this vector, that is magnitude of a2 bar minus a1 bar, its cross with b cap is equal to, magnitude of this means 1 by 3 into square root of minus 1 square plus minus 0, that is 0 square plus minus 1 square, and so it is equal to 1 by 3 into square root of minus 1 square 1 plus 0 square 0 plus minus 1 square 1. So it is equal to 1 by 3 into square root of 2. So it is equal to square root 2 upon 3. So therefore the required or therefore the distance between parallel lines is equal to square root 2 upon 3 units. Square root 2 upon 3 units. So in this way, if we have given any two parallel lines, then we can find the parallel distance or distance between two parallel lines. That is square root 2 by 3 units. Next, see, we have seen distance of a point from a line as well as distance between two parallel lines. Now we see the new concept, that is skew lines. Skew lines. See, we know that if any two lines are parallel to each other, these are the two lines which are parallel to each other, then the distance between these two lines is nothing but the perpendicular distance between these two lines. So if this is P and this is M, then this PM is the shortest distance between these two lines, and as the lines are parallel, that shortest distance is constant everywhere. So if lines are parallel, then the distance between them is the perpendicular distance between these two lines, or that is the shortest distance. Now if lines are not parallel, means lines are intersecting. If lines are intersecting like this, then the shortest between these two lines is 0, because these two lines intersect each other. It means that the shortest distance between them is 0. See, if lines are parallel, then shortest distance between them is the distance between these two lines, and that is constant. If the lines are intersecting, then the shortest distance between them is 0. Now, if lines are not parallel, lines are not intersecting, then such lines are called skew lines. If lines are neither intersecting nor parallel, then these lines are called as skew lines. And these skew lines are this is three-dimensional geometry, x-axis, y-axis, z-axis. This is origin O. This is origin O. So this is point A, B, C, P, Q, R, S. So So if you observe these two lines, if this is L1 and this is L2, then these two lines L1 and L2 are skew lines. They never intersect each other. The line L1 is gone diagonally along the plane CRPS or SCRP, and the line L2 goes diagonally in the plane SPQA or AQPS. So these two lines L1 and L2 are skew lines. They never intersect each other. They are not parallel to each other. So such type of lines are called skew lines. And now we have to find out the distance between these two skew lines, shortest distance between these two skew lines, and shortest distance between these two skew lines is the length of the segment which is perpendicular to both the lines. Shortest distance between these two skew lines is the length of the segment which is perpendicular to both the lines. And now we have to study shortest distance between skew lines. So distance between skew lines. The distance between the skew lines R bar is equal to A1 bar plus lambda into B2 bar, B1 bar, and R bar is equal to A2 bar plus lambda into B2 bar is modulus of A2 bar minus A1 bar, its cross dot with B1 bar cross B2 bar, divided by magnitude of B1 bar cross B2 bar. So this, it is modulus of. So this formula gives us the shortest distance between the two skew lines. If this is line L2 and this is line L1, if this equation of this line is R bar is equal to A1 bar plus lambda into B1 bar, and if this line is R bar is equal to A2 bar plus lambda in L2 means 2 here, sorry, it is A2 bar plus lambda into B2 bar, and this is L1 means A1 bar plus lambda into B1 bar. So this is the segment which is perpendicular to both the lines. So as the equation of line L2 is R bar is equal to A2 bar plus lambda into B2 bar, means we have the position vector of the point on the line, that is A2 bar. So if this is point A, so its position vector is A2 bar. If this is point B, then the position vector of this point B is A1 bar. So, and this segment is the shortest distance between these two lines, and that shortest distance is given by this formula. So we see some remarks. First, see, we know that if two lines intersect each other, then shortest distance between them is 0. If two lines intersect each other, then shortest distance between them is 0. That is first remark. And if two lines intersect each other, then shortest distance between them is 0, and shortest distance between them is if this one, then A2 bar minus A1 bar, its dot with B1 bar cross B2 bar is 0. So first remark, two lines intersects each other, two lines intersect each other if and only if shortest distance between them is 0. First remark. Now second one. Lines R bar is equal to A1 bar plus lambda into B1 bar plus and R bar is equal to A2 bar plus lambda into B2 bar intersects each other if and only if A2 bar minus A1 bar its dot with B1 bar cross B2 bar is equal to 0. See, the shortest distance between these two lines is this formula or this distance. Now if these two lines intersects each other, it means that shortest distance between them is 0, means the value of this expression is 0, and we know that this is equal to 0 only when numerator is 0, and what is numerator? That is A2 bar minus A1 bar dot B1 bar cross B2 bar is equal to 0. So these two lines intersects each other, then the shortest distance between them is 0, or if shortest distance between them is 0, then these two lines intersects each other. This is second remark. Now let's see third remark. Remark number first, second, third. If here the equation of lines are given in the form of vector form, so if lines are given in Cartesian form, if the lines x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1, and x minus x2 divided by a2 is equal to y minus y2 divided by b2 is equal to z minus z2 divided by c2 intersect each other, then determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 is equal to 0. Means if the lines are given in Cartesian form and if these two lines intersects each other, then the value of this determinant is 0, or if the value of this determinant is 0, then these two lines intersects each other. So here we have seen skew lines, distance between skew lines and remarks on them. So we see the examples on the skew lines. So next question is find the shortest distance between the lines. Find the shortest distance between the lines R bar is equal to 4i cap minus j cap plus lambda into I cap plus 2j cap minus 3k cap, and R bar is equal to I cap minus j cap plus 2k cap plus mu into mu into I cap plus 4j cap, I cap plus 4j cap minus 5k cap. See, here the equation of lines are given. These two lines are skew lines and we have to find out the shortest distance between them. So the given equation of lines are R bar is equal to 4I cap minus j cap plus lambda into I cap plus 2j cap minus 3k cap, and R bar is equal to I cap minus j cap plus 2k cap plus mu into I cap plus 4j cap minus 5k cap. So here A1 bar is equal to this one. R bar is equal to A1 bar plus lambda into B1 bar. And the second equation of line is R bar is equal to A2 bar plus mu into B2 bar or lambda into B2 bar. Lambda and mu are parameters. So A1 bar is equal to 4I cap minus j cap. B1 bar is equal to I cap plus 2j cap minus 3k cap. A2 bar is equal to I cap minus j cap plus 2k cap, and B2 bar is equal to I cap plus 4j cap minus 5k cap. So once we get A1 bar, A2 bar, B1 bar, B2 bar, then we can find the shortest distance between these two lines, and it is given by the formula modulus of A2 bar minus A1 bar dot B1 bar cross B2 bar. Means first we require A2 bar minus A1 bar, A2 bar minus A1 bar. It is equal to, see, A2 bar minus A1 bar, I cap minus 4I cap minus 3I cap minus j cap, and this minus minus become plus j cap, so it is 0 j cap. Now 2k cap, here the coefficient of k cap is 0, so 2k cap minus 0k cap, that is 2k cap. This is your A2 bar minus A1 bar. Now find out B1 bar cross B2 bar. B1 bar cross B2 bar is equal to determinant I cap, j cap, k cap. So second row is the coefficients of ijk in B1 bar, and this is 1, 2, minus 3. 1, 2, minus 3. Third row is the coefficients of ijk in B2 bar, that is 1, 4, minus 5, which is equal to I cap in bracket, leave first row and first column. So first row and first column, so 2 into minus 5 minus 10 minus 4 into minus 3 minus 12, and minus of minus 12 plus 12 minus j cap in bracket, leave first row second column, 1 into minus 5 minus 5 minus 1 into minus 3 minus 3, and minus of minus 3 plus 3 plus k cap in bracket. Now leave first row and third column, so 1 into 4 4 minus 1 into 2 2. So it is equal to 12 minus 10 2, so it is 2I cap minus j cap in bracket, 3 minus 5 minus 2 plus 4 minus 2 2 k cap. So therefore B1 bar cross B2 bar is equal to 2I cap minus minus become plus 2j cap plus 2k cap. So this is B1 bar cross B2 bar. Now what is magnitude of B1 bar cross B2 bar? B1 bar, magnitude of B1 bar cross B2 bar is equal to square root of 2 square plus 2 square plus 2 square. It is equal to square root of 4 plus 4 plus 4, and it is square root of 12. So magnitude of B1 bar cross B2 bar is also known. So now find out A2 bar minus A1 bar, its dot with B1 bar cross B2 bar, it is equal to, what is A2 bar minus A1 bar? It is minus 3i cap plus 0j cap plus 2k cap. Its dot with B1 bar cross B2 bar. What is B1 bar cross B2 bar? It is 2i cap plus 2j cap plus 2k cap. 2i cap plus 2j cap plus 2k cap. So it is equal to, it is minus 3 into 2 plus 0 into 2 plus 2 into 2. So it is equal to minus 6 plus 0 plus 4. So 4 minus 6 is minus 2. So this is A2 bar minus A1 bar dot B1 bar cross B2 bar. The shortest distance between the given lines is equal to modulus of A2 bar minus A1 bar, its dot with B1 bar cross B2 bar, divided by magnitude of B1 bar cross B2 bar. Now in this formula put the values. A2 bar minus A1 bar dot B1 bar cross B2 bar is minus 2, modulus of minus 2 divided by the magnitude of B1 bar cross B2 bar. Magnitude of B1 bar cross B2 bar is square root of 12. So it is square root of 12. So which is equal to, see, minus 2 upon minus, this is distance and it is in modulus sign. Modulus gives us always positive value. So it is 2 upon square root of 12. It is equal to 2 upon, the square root of 12 can be written as square root of 4 into 3. So square root of 4 is 2. So 2 upon 2 into root 3. Here square root of 4 is positive 2 plus 2 because we have to take modulus sign, or we have to take, modulus value, positive value, absolute value. So 2 upon 2 into square root of 3 and it is equal to 1 upon root 3. So 1 upon root 3 is the shortest distance between the lines. So which is equal to 1 upon root 3 units. So 1 upon root 3 units, that is the shortest distance between the two skew lines or between the two given lines. So we see the next problem. Find the shortest distance between the lines. Or we see some different type of question. Determine whether the following lines intersect each other. See the next question. Determine whether the lines R bar is equal to I cap minus J cap plus lambda into 2i cap plus k cap, and R bar is equal to 2i cap minus j cap plus mu into I cap plus j cap minus k cap intersect each other. Intersect each other. See, we have to check whether these lines intersect each other or not. We have seen in one of the remark that the two lines R bar is equal to, if we have two lines R bar is equal to A1 bar plus lambda into B1 bar, and R bar is equal to A2 bar plus lambda into B2 bar. These two lines intersect each other, then we have shortest distance between them is 0, that is A2 bar minus A1 bar, its dot with B1 bar cross B2 bar is equal to 0. If this dot product is 0, then these two lines intersect each other. So first, in this case, to solve this question, first we check the dot product of these two vectors. So let's see the solution. See, here A1 bar is equal to I cap minus j cap plus, now the coefficient of means k cap term is absent, so we can write it as 0 into k cap. This is your A1 bar. Now B1 bar is equal to, see this is B1 bar, 2I cap plus the coefficient of j cap is 0, so we can write it as 0 into j cap plus k cap. Similarly, A2 bar is equal to 2I cap minus j cap plus 0 k cap, and B2 bar is equal to I cap plus j cap minus k cap. Now A2 bar minus A1 bar, it is equal to A2 bar minus A1 bar. This is 2 minus 1, that is I cap, minus j cap, and this plus j cap. Minus j cap plus j cap becomes 0 j cap. 0 minus 0, that is 0 k cap. This is A2 bar minus A1 bar. Now find out B1 bar cross B2 bar. It is equal to determinant I cap, j cap, k cap. B1 bar cross B2 bar. So first, second row is the coefficients of ijk in B1 bar, that is 2, 0, 1. And third row is the coefficients of ijk in B2 bar, that is 1, 1, minus 1. It is equal to I cap in bracket, leave first row, first column, 0 into minus 1, 0, minus 1. Minus j cap in bracket, leave first row, second column, 2 into minus 1, minus 2, minus 1. 2 into minus 1, minus 2, minus 1 into 1, 1. Plus k cap in bracket, leave first row, third column, 2 into 1, 2, minus 1 into 0, 0. So it is equal to minus I cap minus and this minus become plus 3 j cap and plus 2 k cap. So this is B1 bar cross B2 bar. So we have B1 bar cross B2 bar as well as now A2 bar minus A1 bar, its dot with B1 bar cross B2 bar is equal to A2 bar minus A1 bar I cap plus 0 j cap plus 0 k cap into its dot with B1 bar cross B2 bar. What is B1 bar cross B2 bar? That is minus I cap plus 3 j cap plus 2 k cap. It is equal to, it is 1 into minus 1 plus 0 into 3 plus 0 into 2. So which is equal to 1 into minus 1 minus 1 plus 0 into 3 0 plus 0 into 2 0. So it is equal to minus 1. So A2 bar minus A1 bar dot B1 bar cross B2 bar is equal to minus 1. this is not equal to 0, so therefore the given line does not intersect each other. So therefore, or A2 bar minus A1 bar, its dot with B1 bar cross B2 bar is not equal to 0, so therefore the given lines does not intersect each other. So today we stop it here.